Hello students, in the previous video we have learnt about differentiation, and in this video let us learn about integration. The main purpose of integration is to find area under the given curve. Suppose the graph for given function comes like this. So I want you to find area under this curve. Is it as simple as finding area of a rectangle, or finding area of a square, or finding area of a circle? No, it is not. So for such complex curves, how to find the area under this curve? Okay. So for that purpose, I will take a small strips, rectangular strips cut out of this given curve. Now what I will do? I will find the area of all these strips. Then I will find the total area as A. But this area is not close to the total area under this given curve. Okay. So here, let us make these strips much more smaller. Earlier I have taken the width of the strip as delta x this much big. The width of the strip is delta x this much big. Now let us make this delta x much more smaller so that the delta x value almost becomes 0. Then the strips become thinner and thinner. Okay, what I am doing here, earlier I have taken the width of the strip as delta x, which is little bit wider. Now here let us reduce this delta x value to almost equal to 0. Okay, now I will have more number of rectangular strips. Now I will find out area of all these strips individually. Then I will add them up. Then the area I will get is close to the area under the given curve. Okay, so how many strips you take under this curve, that much accurate answer you will get for the area. Okay, but this is a complex process to do so. That's why we have the tool called integration to find the area under such curves. Okay. Now, what is the difference between integration and differentiation? The basic difference is they are reverse of each other. Integration is the reverse process of differentiation. Differentiation is the reverse process of integration. For example, derivative of x square is 2x and integral of 2x is x square. They are quite opposite to each other. Okay, to understand this, let us take an example. Here I have plotted a graph for y by x is equal to 2. That means the slope delta y by delta x is equal to 2. Since it starts from origin, I can write it as y by x is equal to 2. So what it becomes, y equal to 2x, isn't it? Now the function is y is equal to 2x, isn't it? Y is equal to 2x, right? So it is in the form of a straight line. Y equal to 2x is in the form of straight line equation. So we get a straight line here. Okay. Now let us find area under this graph. Look at the shape. It is in the shape of a rectangle triangle, isn't it? So what is the area of the triangle? It is half into base into height. Half into base, let us take it as x, and the height of this triangle is y, isn't it? So half into base into height. Half into base x into height is what? We got y equal to 2x. Let us substitute here. So we get a total x square. 2 gets cancelled. X into x, x square. Okay. So what does area give us? Area gives us integral. Integral of the given function. Area gives us integral of the given function. So for y equal to 2x, the integral we got is x square. That is what? Integral of 2x is x square. And we know derivative of x square is 2x. That means they both are opposite to each other, isn't it? Now coming to the notation of integral, here the integral is noted with a symbol stretched s, isn't it? It looks like a stretched s. Okay, why only s? Because s is derived from sum, the word sum. What is integration? Here integration means summation. Integration means summation, means adding. Okay, what we have added here? We have added all these areas together so that we get a total area. Okay, so integration basically means it is a summation. So sum. That's why the notation for this integral is in the form of a s, stretched s. Okay, and it is pronounced as a integral. Fine. Now let us take an example. Integral x square dx is equal to x cube by 3. If we evaluate this one, we get a x cube by 3. In addition to that, we get plus c. Okay, how we get x cube by 3, we will learn in the next part of the video. But let us look at this term c here. What is this c? C is a constant. So what is the necessity of this c? We will take an example to understand this. Okay, this c is called a constant of integration. Fine. So now look at this example over here. X cube plus 6, the function x cube plus 6, if you find the derivative of it, you get a 3x square plus 0. Why 0? Because 6 is a constant, derivative of 6 is 0, derivative of x cube is 3x square. Okay, let us do it in the other page. Suppose we have y is equal to x cube plus 6 and another function y is equal to x cube plus 8 and another one x cube plus 2, something like this. So for this function, if you do the derivative of y, you get a 3x square plus 0. Derivative of x cube is 3x square and 6 is 0 because it's a constant. And for this function, if you do the derivative, you get again 3x square plus derivative of 8 is 0. And here also for this one, if you do derivative, you get 3x square and constant, the derivative is 0. So for all these cases, you get the result of derivative is 3x square. Then what happened to this 2, 6, 8? To understand this, let us take one example. Dy by dx is equal to, suppose, x square plus 2. Okay, now dy is equal to x square plus 2 dx. This dx goes to this side, it becomes x square plus 2 times dx. Now let us apply integral on both sides. Let us not bother about the process I am doing now. You just focus on how I am finding the value of a c here. Okay. Now here integral dy, I can write it as 1 dy. Integral 1 dy is y. How it is y, I will explain the next part of the video. Okay. Now as of now, just see how I am finding the c value. Okay. So here it is integral x square plus 2 dx. I can write this as x square dx plus integral 2 dx. Integral x square dx is x cube by 3 plus integral 2 dx is 2x. For this all, there are formulas, we will do that later. But as of now, see, after evaluating this one, we will be remained with c. Okay, so y is equal to x cube by 3 plus 2x plus c. There is a constant c. How to find the c value? So to know c value, we need to know the initial conditions. Suppose the function passes through the coordinate x comma y, which is suppose 1 comma 2. Okay. Now let us put these values over here. Now y value is 2 is equal to x cube by 3. What is x? 1 by 3 plus 2 times of 1 plus c. Okay. Now it is 1 by 3 plus 2 plus c. There is 2 on both sides, 2 gets cancelled. Okay, 0 is equal to 1 by 3 plus c. That implies c is equal to minus 1 by 3. This is how we find the c value after evaluating integral of the given function. Okay. Now, look at this example here to understand the integration much better. Here, there is a tap from which water is leaking. Now, the leaking rate, the flow rate is 1 drop per 1 second. Suppose the flow rate here is 1 drop per 1 second. What does it mean? Every second, there is a drop falls onto this into this bowl. Okay, so 1 drop per 1 second means after 10 seconds how many drops will be filled in the bowl? Yes, 10 drops will be filled in the bowl. Now for this flow rate, let us plot the graph. Flow rate means how many drops are falling per second. Okay, so on x-axis let us take the time, on y-axis let us take the flow. Here at 1 second, what is the flow rate? 1 drop per second. 2 seconds also flow rate is 1 drop per second. So the flow rate is constant here, which is 1 drop per second. Okay, now let us integrate here. What does integrate give us? The sum, isn't it? The sum means here, as these water drops fall into the bowl, the water is getting added up here. Initially 0 seconds no water, 1 second 1 drop is there, another second another drop is there, plus another second another drop is there. This water is getting accumulated in this bowl. So that sum we will get after doing the integration. Okay, now let us integrate here for the given graph. Again, take this graph again. Flow is on y-axis, time is on x-axis. Okay, so after 10 seconds passed, what is the total volume of water filled in the bowl? How we can find out that? We can find out that by finding the area under the graph, because area under the graph gives us what? Area under the graph gives us integration. Okay, now in 10 seconds how many drops are filled? Now since it is in a rectangle form, the shape of a rectangle, what is the total area? It is length into breadth. So 10 into 1, 10 drops. How many drops are filled here after 10 seconds? 10 drops are filled in this bowl. Okay, so it's a basic simple example. We will make it complex in the further slides. Okay, so area under graph gives us integration. So with the flow rate of 1 drop per second, in 10 seconds how many drops will be accumulated? 10 drops will be accumulated. That means the integration will give you the total value or the summed up value if you know the rate of this change. If you know the flow rate, you can find out the total volume after given time. That is the basic purpose of integration. Okay. Now from this example, what we can conclude? We can conclude that for the flow rate of 1, the volume increases by x. For the flow rate of 1, the volume increases by x. What does it mean? Let us take the graph again. So we have taken flow on the y-axis and time on x-axis. What is the flow rate we have taken? We have taken flow rate as a 1. What does it mean? 1 drop per second. Okay. Now in 1 second, how many drops are filled in this one? Only 1 drop. In the another second, how many drops are there? It is already 1 drop is there, and 1 more drop will be filled in this one. Another second, 1 more drop will be filled. So total 3. Total volume is 3 drops. Okay. Another second, 1 more drop will be filled. So total volume is 4 now. Okay. So for as x becomes 1, the volume is 1 drop. Okay. Now as x becomes 2, the volume is 2 drops. As x becomes 3, the volume is 3 drops. As x becomes 4, the volume is 4 drops. That is what the meaning of the statement here. For the flow rate of 1, the volume increases by x. The volume increases by x. When x is 1, volume is 1. When x is 2, volume is 2. When x is 3, volume is 3. That means for the flow rate of 1, the volume increases by x. Whatever the x value is there, that much volume will be there in the bowl. Okay. That means this, let us understand about this one more better. Here flow rate 1 means the slope of the graph is 1, isn't it? This is what? Dy by dx. On x-axis volume is, on y-axis volume is taken, on x-axis time is taken, isn't it? Just now we have seen that the volume is proportional to the flow rate, isn't it? If the flow rate is more volume of water will be filled in this, isn't it? Now see here, for the given flow rate 1, the slope of the graph is 1, dy by dx is 1. Okay, here on y-axis we have taken volume and x-axis we have taken time. Okay, now look here. Suppose here from this tap water is being dropped into the bowl. 1 second, 1 drop. That means if x is 1, the volume is 1. Volume is 1 drop. If x is 2, the volume is 2 drops. If x is 3, volume is 3 drops. So it is happening in this way. Okay. Now again look at this graph again. On y-axis we have taken volume, on x-axis we have taken time. Now let us take some values for the time. I divide this time axis into 2 seconds each. So 2 seconds, how many drops are filled? 2 drops are filled. In another 2 seconds, how many drops are filled? Another 2 drops are filled. In another 2 seconds, another 2 drops filled. So now, first 2 seconds, what is the volume? 2. Next first 4 seconds, what is the volume? 4. First 6 seconds, what is the volume? 6. Isn't it? So we can conclude that with a flow rate 1, the water volume increases by x. So how much is there on the x? The volume increases in the same way. That is, an integral of 1 is x. Remember this point, integral of 1 is x. Okay, let us move on to next slide. Here I have provided list of formulas for integration. Okay, so integral 0 dx is constant c. Integral 1 dx is x plus c. Integral x power n dx is x power n plus 1 by n plus 1 plus c. Okay, so here this rule is called power rule, which is the formula we frequently use in our physics. Okay, now integral e power x dx is e power x plus c. Fine. So these are the rest of the formulas that you have to memorize. Now, what are the definite and indefinite integrals? So here in this curve, if I ask you to find the integral of this function, I have not specified any limits. You have to find the area under the graph throughout, isn't it? So I have not specified any limits. That is, from here to here you find. I did not say like that. So such integrals are called definite integrals. Sorry, indefinite integrals. Now, suppose for the same function, if I specify limits from here to here, from A to B, if I ask you to find the area under the curve by setting some limits, such integrals are called definite integrals. Integrals without limits are called indefinite integrals. Integrals with limits are called definite integrals. Okay. Now, let us make use of our power rule. What is the power rule? Integral x power n dx is equal to x power n plus 1 by n plus 1 plus c. Okay. What is this plus c here? Earlier we have seen the example of bowl and a tap leaking the water. Okay. So if the bowl has already some water, before water comes from the tap, if the bowl already has some water, that is what? Our c, isn't it? Initial conditions. I told you, initial conditions will specify the value of c. Now, let us use this formula here. Integral 2x square dx. 2 is a constant, so bring it out of the integral. 2 integral x square dx. What is the power here? N is the power, isn't it? So here in place of n, 2 is there. So it becomes x power n plus 1, means 2 plus 1 by n plus 1. That is 2 plus 1 plus c. What is the value? It is 2 times of x cube by 3 plus c. This is the answer for the given integral. Okay. Now let us evaluate integral root x dx. Integral root x dx. So this root x can be written as x power 1 by 2 dx. Isn't it? So now in place of power it is 1 by 2. Now apply the power rule. So after applying power rule we get x power 1 by 2 plus 1 upon 1 by 2 plus 1 plus c. So what is the final answer? X power, if you evaluate this one, it becomes e by 2, x power 3 by 2 by e by 2 plus c. Okay, you can simplify this one further. Next, another rule in the integration is sum rule. Here, what is the sum rule? Here, there are two functions in the integral. Okay, first one is cos x, another one is x, and they are getting added up. So, whenever there is sum between the two functions, we have to use this sum rule. What does the sum rule say? It says, let us split up this given two functions as this integral cos x dx plus integral x dx. That means you have to apply this integral to both of them separately. Okay. Now, what is integral cos x dx? In the provided list of formulas we have seen, integral cos x dx is sin x plus c. Okay. So, this is sin x plus integral x dx. What is integral x dx? That also we have seen in the given formulas. Integral x dx. X dx means in place of n, 1 is there. We can write x as x power 1. So, here to evaluate integral x dx, we can write it as x power 1 dx. Okay. So, by using power rule, we can write x power 1 plus 1 by 1 plus 1 plus c. Okay. So, the final answer is sin x plus x square by 2 plus c. Fine. Now, what is the difference rule? Difference rule same as sum rule. Here also we have to write the functions separately. Integral x square dx minus integral e power x dx. What is integral x square dx? By using power rule, we can write x power 2 plus 1 by 2 plus 1 minus integral e power x dx. It is e power x only. Okay. So, the final answer is x cube by 3 minus e power x. Sorry, plus c will be there, plus c. Okay. Since it is indefinite integral, we have to write a plus c. Now, definite integral means we have to find the area under the curve between the specified limits. Here 1 and 2 are the specified limits. Okay. So, here how to deal with definite integral. You know, here again 2 is a constant, bring it out of the integral. Let us write a integral x dx. Limits are 1 to 2. Here 2 is called upper limit and 1 is called lower limit. Okay. So, now let us see how to solve this one. Here again 2 is a constant. Integral x dx. Integral x dx is what? X power 1 plus 1, that is x square, by 1 plus 1, that is 2. Now, let us apply the limits. 2 is the upper limit, 1 is the lower limit. So, 2 times of x square by 2. Put this upper limit first. So, 2 square by 2 minus, put this lower limit now, 1 square by 2. Okay, this becomes 2 times of 4 by 2 minus 1 by 2. 4 by 2 minus 1 by 2. This becomes 4 minus 1, which is 3. 3 is the answer for this definite integral. Okay. Now, let us look at one more example. Here, integral 2 to 3 4t square plus 2t dt. Again, here, let us apply the sum rule. Integral 2 to 3 4t square dt plus integral 2t dt. And limits are same for this 2 to 3. Now, 4 is a constant, bring it outside. Integral 2 to 3 t square dt plus, bring the 2 outside, 2 to 3 t dt. So, let us evaluate this one. Now, 4 times of integral t square dt is t cube by 3. And limits are 2 to 3 plus 2 times integral t dt is t square by 2. Limits are 2 to 3. Now, substitute the upper limit first, that is 3 cube by 3 minus, substitute the lower limit now, 2 cube by 3 plus 2 times of, substitute the upper limit, that is 3 square by 2 minus, substitute the lower limit, 2 square by 2. Okay, so you can simplify this one to get the final answer. Now, integral 0 to pi by 2 cos theta d theta. So, here we make one observation out here. Here, whatever is the variable, this operator is in the same terms. If it is the variable is x and it is dx. If the variable is in t here, here the operator is dt. Now here it is in theta, so here we have d theta. Okay, remember this. If suppose cos x d theta is there, x must be the angle, so it is equal to cos theta d theta. But if any function here, suppose t square plus 2t plus 3 times of dx is there, you have to modify this in terms of x. Then you have to evaluate the integral. Okay, that we will see in our physics numericals how to do that. But as of now, just learn the basics. Okay, so integral 0 to pi by 2 cos theta d theta. So what is integral cos x dx? Integral cos x dx is sin x, we know that. So this becomes sin theta. The limits are 0 to pi by 2. Okay, so substitute the upper limit first. It will be sin pi by 2 minus substitute the lower limit. It is sin 0. Okay, sin pi by 2 is 1, sin 0 is 0. So the answer is 1 for the given integral. Okay, now the next one is integration by parts. Integration by parts is a rule when two functions are multiplied together. In the given integral, if there are two functions which are getting multiplied, then we use the rule called integration by parts. Okay, so what does the rule say here? If suppose we have integral u v dx, it can be written as integral u integral v dx minus integral u dash integral v dx and dx. Okay, so it looks complex, but it is easy to remember. Here what do we have? U v dx. Again we have u v dx, again u v dx, and then dx. Okay, simply put integral over here. After minus, again put the integral in the bracket, put the integral, and here minus and here u dash or u prime. Okay, so whichever way you want to remember, you can remember. Now how to apply this formula? Here in the given example we have integral x cos x dx. How much is the answer? Okay, so here we have two functions which are getting multiplied. So how to evaluate this one using integration by parts? The very first step is we have to choose which is u, which is v. So in this formula we have u and v, no, two functions u and v. But here which function is u, which function is v. Okay, so first choose u and v. Then next step is find the derivative of the u. If you choose cos x as u, the derivative is minus sin x, isn't it? So the second step is to find the derivative of the u. Next integrate v. Here we have integral v dx, no? So we have to integrate v. Then substitute all of them in the given rule, integration by parts. Okay, so to evaluate the given question here, integral x cos x, I will choose u as x. I will choose u as x and cos x as b. Okay, why only u as x, why only v as cos x, I will explain you in the next part of the video. Okay, as of now just take v equal to x, v equal to cos x. Now what's the derivative of x? Derivative of x is 1 and integral of cos x is sin x. Okay, so we are done with the second and third steps. Now fourth step is what? Substitute in the given by parts rule, integration by parts rule. Now integral x cos x is the one we have to evaluate. So what is the first one here? U. So u means here x, integral v dx. V dx means here we have cos x dx minus integral u dash. Integral u dash means here u we have taken x, so x dash bracket integral v dx. Here v is cos x dx and then again dx. Okay, so we can evaluate this one. X integral cos x dx is what? Sin x minus integral derivative of x. Here x dash means derivative of x. Derivative of x means what? 1. Okay, x derivative is 1. So integral 1 integral cos x dx. Integral cos x dx is sin x and then dx. So x we write as is, sin x we write as is, minus as is. Now integral sin x dx. Integral sin x dx means minus cos x. So the final answer is x sin x minus of minus plus cos x plus c. So this is how you make use of the integration by parts. Okay. Next, coming to choosing u and v. How to choose u and v? Is it up to us? No. There are certain rules to follow before choosing u and v. So what are they? Now first point to remember, you should get simpler. The function which you are taking as u, that should get simpler when you differentiate it. V does not get any more complex when you integrate it. Okay, remember these 2 points. Now there is another shortcut to choose u. To choose u, we have another shortcut that is called ILATE. I is what? Inverse trigonometric functions. That is sin inverse x, cos inverse x, tan inverse x. So such inverse trigonometric functions we have to give the preference to choose as a u. Okay. Next, in the order next comes logarithmic functions. Okay, log x or log y. Such logarithm functions comes in the given integral. Then we have to prefer u. Sorry, you have to prefer these logarithm functions to take it as a u. Next, algebraic functions, then trigonometric functions, then exponential functions. We have to follow this order to choose the u. Okay. Now let us take one example over here. We have here integral e power x sin x dx. Which one we have to choose as u? So let us follow this order. ILATE, inverse trigonometry, logarithms, algebra, and trigonometric functions, exponential functions. Okay, ILATE. Okay. Now here there are no inverse trigonometric functions and no logarithmic functions, no arithmetic. But here are trigonometric and exponential functions. So which comes first? In the order, trigonometric functions come first. So take trigonometric function as u and then exponential as a v. Okay. So let us take sin x as a u, e power x as a v. Got the point? In the order ILATE, whichever comes first, that we have to take it as a u. So here trigonometric functions sin x, let us take this as a u. Okay. And then e power x as a v. Now apply the formula integration by parts. Okay. Now here, if you apply this formula to e power x sin x dx, where sin x is u, e power x is v. Okay. So now here in place of u, we have sin x integral v dx. V is what? E power x dx minus integral derivative of u. Derivative of sin x is cos x, and in bracket we have v dx. V is what? E power x dx. Okay, and dx. Now sin x integral e power x dx is simply e power x minus integral cos x and integral e power x dx. This is e power x and dx. Here again we have integral cos x e power x dx. Again there are two functions getting multiplied here. That means to evaluate this one, we again have to apply integration by parts. Okay. So what is our rule to choose u? Here choose u as a followed in this thumb rule. What is that? ILATE. So here trigonometric function comes first. So the trigonometric function should be taken as u and then exponential should be taken as a v. Okay. Now consider cos x as u and e power x as a v. Apply the integration by parts once again. Okay. So let us take cos x as u, e power x as a v. Now write this one as it is sin x e power x minus of integral cos x e power x dx. We are going to apply integration by parts for this part. Okay. So here in place of u, what is there? Cos x integral v dx. What is v dx here? E power x dx minus u dash or derivative of u. Derivative of u is what? Derivative of cos x is minus sin x. Isn't it? Integral of derivative of u, which is minus sin x, into integral v dx. Integral v dx means e power x dx times dx. Okay. Now that is equal to sin x e power x minus cos x. Integral e power x dx is simply e power x minus of minus plus integral sin x, and integral e power x dx is e power x and dx. Okay. So what do you get here? Sin x e power x minus cos x e power x, and minus times plus is minus integral sin x e power x dx. Okay. Now on the LHS side, what do we have? We have the given integral here, that is integral e power x sin x dx. On the right RHS side also we have same term, integral sin x e power x dx. So let us bring this to LHS side. So it becomes 2 times of integral e power x sin x dx, that is equal to sin x e power x minus cos x e power x. Okay. So we are asked to evaluate only this one. So integral e power x sin x dx is equal to sin x e power x minus cos x e power x upon 2, and you can use plus c here. This is the final answer for the given integral. Next one, the very important one in integration is integration by substitution method. This is simply the reverse process of chain rule. We have learned chain rule in the differentiation. So this process of substitution in integration is simply the reverse of chain rule. Okay. Now here directly step into this example here, integral cos x square 2x dx. So here the thing is, first you have to choose u. Here I'll choose x square as u, and this one as du. So other than this one, I'll tell you one more shortcut for this. It may be confusing for you. Now here substitution method, first I will choose x square as u. Okay. Then I will find du by dx. First, what is u here? U is equal to x square. Then du by dx is equal to 2x. Isn't it? Derivative of x square is what? 2x. Now I have du is equal to 2x dx. Du is equal to 2x dx. But here I have 6x dx. 6x dx. But here I have 2x dx. If I multiply with 3 on both sides, what I will get? I will get 3 du is equal to 6x dx. 3 du is equal to 6x dx. So in the question we have integral cos x square 6x dx, isn't it? So in place of x square, what I have assumed? I have assumed u. In place of 6x dx, what I got? I got 3 du. Okay. So let us read it this one. Integral cos in place of x square it is u. In place of 6x dx it is 3 du. Isn't it? So here I can write it as integral 3 cos u du. What's the value for this? Bring out this 3 outside since it is a constant. Integral cos u du. Integral cos u du. What is the formula for integral cos u du? It becomes 3 times of sin u. Isn't it? Plus c. 3 sin u plus c. So 3 sin, what is u? U we have assumed as a x square. So sin x square plus c. This is the answer for given integral. Okay, this is how you make use of a substitution method. So let us look at one more example here. Here now I will assume this x square plus 1 as u. So which one we have to assume as u, that comes by practice here. Okay, so whichever term you are going to choose as u, if you find the derivative of that, I get 2x, no? Here if I find the derivative of the term, I get 2x. Here I have x. Okay, so choose u such that its derivative should contain the term. Here I have derivative of x square plus 1 as a 2x, no? So here in this one I have x, and here also I have x. So choose u in that way. Okay, so here in this example I have integral x by x square plus 1 dx. Okay, so what is the first step here? We have to substitute x square plus 1 by u. Okay, then find the derivative of u. Du by dx is equal to, what is that? 2x. 1 anyhow, derivative is 0. So now du is equal to 2x dx. Okay, but I have here only x dx. If you look here, I have x dx, but here I have 2x dx. So du by 2 is equal to x dx, isn't it? From this I can write du by 2 is equal to x dx, isn't it? Now rewrite the given integral x by x square plus 1 dx. So in place of x dx, I can write du by 2, du by 2, 1 by x square plus 1. In place of x square plus 1, I can write u. So this is simply, I can bring 1 by 2 outside. Now the integral becomes 1 by u du. What is 1 by u du? It is same as integral 1 by x dx. What is integral 1 by x dx? It is ln x plus c, isn't it? Now here the answer is 1 by 2 times natural logarithm u plus c. This is the answer for the given integral. Next one. Here again the function is like this, so we have to go for substitution method. So here I'll assume x plus 1 as a u. Then find the derivative of u. That means du by dx. Du by dx is what? 1 here, isn't it? So du is equal to simply dx. Du is equal to dx. Substitute over here. Now integral x plus 1 whole cube dx. In place of x plus 1 I have assumed u. So integral u cube, and dx I got du. Okay. So what is u cube du? It is u power 4 by 4 plus c, isn't it? So what is u power 4? U I have taken as x plus 1. It is x plus 1 power 4 by 4 plus c. This is how you can make use of a integration by substitution method. Okay, that's it for the day.